myself Prabha Ranjay, working as an assistant professor from EC department at SNS College of Technology. In this video lecture, I am going to discuss about the topic name is linear phase FIR filter from unit 3, that is FIR filter design. From the subject name is digital signal processing. Let I discuss. Yeah. First of all, what is linear phase? Yeah, and FIR filter is said to have linear phase. It is if its phase response is a linear function of frequency. This is a very desirable property in signal processing, especially in audio, image, communication system, because it is preserve the waveform shape of signals. No phase distortion. Then an FIR filter has linear phase if the phase response psi of omega satisfies, which is psi of omega equal to omega into tau, where omega is nothing but the angular frequency, tau is nothing but the constant delay or group delay. This means all frequency components are delayed equally, resulting in no phase distortion. Then types of FIR filter. Types of FIR we will discuss later. Next one is what is mean by FIR filter? FIR filter, the mathematical term of FIR filter is nothing but the y of n equal to summation k equal to 0 to n. N is nothing but the length of the filter. N h of k into x of n minus k. H of k is nothing but the filter coefficient or else impulse response. X of n is nothing but the uh, input signal. And this is the types of linear phase FIR filter. There are 6 possible types. First one is symmetric impulse response with n is odd, and symmetric impulse response with n is even. Then anti-symmetric impulse response with n is odd, anti-symmetric impulse response with n is even. Symmetric impulse response with n is odd, anti-symmetric impulse response with n is odd. These all are the types of linear phase FIR filter. Next one is it have some condition. This is the condition for linear phase FIR filter, um, uh, which means for symmetric there are two conditions, which means there for symmetric h of n equal to h of n minus n. For anti-symmetric h of n equal to minus h of n. And for odd and even, let me see, symmetric for odd equals h of n condition is h of n is nothing but the impulse response, h of n equal to h of n minus 1 minus n. And symmetric for even is same thing. Anti-symmetric odd and even is h of n equals minus h of capital N minus 1 minus n. And symmetric odd is h of n both. Symmetric means both positive and negative value is same, and sign is the differ. H of n equal to h of minus n, which is the symmetric odd, and anti-symmetric odd is h of n and h of minus n equal to minus h of n. And next one is this is the summary of A omega frequency response linear phase FIR filter. Sorry, magnitude function linear phase FIR filter. For symmetric odd, we know the condition is h of n equal to h of n minus 1 minus n, and magnitude function is h of n minus 1 divided by 2 plus summation small n equal to 1 to n minus 1 divided by 2 into 2 into h of n minus 1 divided by 2 minus n cos of omega n. This is the symmetric. odd. And second one is, you can see here, second one is symmetric even. Both symmetry condition is same for both odd and even. H of n is which is equal to h of capital N minus 1 minus n. Capital N is nothing but the length of the filter. And the next one is antisymmetric. Uh, Antisymmetric, odd is nothing but the you can see the value of magnitude function, and the condition already we discussed the condition h of n equal to minus h of n minus 1 minus n. This is the condition for antisymmetric. Okay. Here you can see the for even and symmetric odd and symmetric antisymmetric odd. Already we have discussed the condition of the symmetric and antisymmetric for both the odd and even. Here you can see the value of what is the formula for the magnitude function. And let me do one small classroom activity. Form one group and let you share your self intro. Okay, okay, let me continue. Let me continue. And linear phase FIR filter, both magnitude function and a phase response of FIR filter when impulse response symmetric odd. This is the symmetric even. And antisymmetric odd, this is the antisymmetric even. And design techniques for linear phase FIR filter. There are three techniques for linear phase FIR filter are available. First one is Fourier series method and window method, and second one is frequency sampling method, and third one is optimal filter design. In this lecture, we will discuss one method, that is Fourier series method. And let me discuss about the procedure for digital FIR filter by Fourier series method or windowing technique. First step is the specification of digital filter. You have to whether it is low pass filter or high pass filter or band pass filter and band limit filter. This desired frequency response hd of e, you have to find the desired frequency response hd of e power j omega. Next is, second step is, you have to find or calculate the desired frequency response, that is hd of n, by taking or by using a inverse Fourier transform. This is the formula hd of n equal to 1 divided by 2 pi integral of minus pi to pi capital hd of e power j omega. This is desired frequency response into e power j omega and into d omega. This is the formula for calculate the desired impulse response. And third step is the nothing but the truncation. Truncate from finite duration sequence from the infinite duration sequence. This is the third step. And fourth step is nothing but the you have to convert get the non-causal transfer function. And the fifth step is convert the non-causal transfer function to causal transfer function. And last step is this. This is the formula for for this conversion. And final step is so you have to draw the suitable structure for realization of FIR filter. These all are the steps to design a digital filter by using Fourier series method. And assessment for this lecture is, first question is define FIR system, and second one is mention the advantage and disadvantage of FIR system, and third one is what are the that means frequency response filter are classified in four types. That four types, which are the four types, and what are the steps involved in designing FIR filter, and fifth step is summarize the frequency response characteristics of linear phase FIR filter, and another one is sixth one is in order to examine linear and non-linear phase characteristics, two delay function, what are the two delay function, and seventh one is Fourier transform of h of n. These all are the assessment of this lecture, and if you have any doubt you can ask me through the comment. Thank you. We will meet in next video. Thank you.